In this video, we are going to discuss the counting techniques. And these are techniques which we can use normally in our computations of probability. So there are three counting techniques that we will discuss. The first, this is called the fundamental principle of counting. The fundamental principle of counting simply states that if you can separate your experiment into k operations, where the first operation can be done in n1 ways, the second in n2 ways, and so on, then the experiment can be performed in n1 times n2 until n sub k ways. The main thing to remember here is that if you can count the number of ways you can do each operation, then all you have to do is to multiply each of those operations, and you will have now the total number of ways that your experiment can be done. So as an example, suppose you want to select a book of each kind from 3 novels, 4 dictionaries, and 5 encyclopedias. In how many ways can we do this? So normally, in order to apply the fundamental principle of counting, you just draw blanks for each of the possible operations of your experiment. In this case, we need one blank to select a novel, a dictionary, and an encyclopedia. So since there are 3 novels, there are 4 dictionaries, and there are 5 encyclopedias, then you just have to multiply these 3 times 4 times 5. And that means there are 60 ways in order to choose one of each kind of book. Another example, how many plate numbers are possible if plate numbers are composed of 3 letters and 3 numbers? So assuming there are no restrictions, okay, we now draw blanks, 3 blanks for the letters and 3 blanks for the numbers. So for the letters, we have 26 letters in the alphabet. So that means for the first 3 blanks, you have 26 possible letters to choose from. While for the digits or the numbers, you will have 10 possible numbers to choose from. Okay, each of the numbers from 1 to 9, and then also 0 is possible. So now that we have listed down the number of ways that you can count each of the characters of the plate number, then you just have to multiply each of these numbers to arrive at the number of possible plate numbers. Okay, so you can count this using your calculator since this is quite a big number. Now, what if the question is how many plate numbers are possible if you cannot repeat letters and you cannot repeat numbers? Okay, so what if the question is how many plate numbers are possible without any repetitions? Okay, so again, we draw blanks, 3 for the letters and 3 for the numbers. So for the first letter, you can choose any letter that you want. So any of the 26 letters in the alphabet. For the second letter, you can choose any letter in the alphabet as long as it is not the same as the first letter. So that means you only have 25 letters to choose from. For the third letter, you can choose any letter in the alphabet except any of the 2 letters that you already chose for the first 2 letters. So now you only have 24 letters to choose from. In the same manner, for the numbers, you will have 10 to choose from for the first digit, only 9 for the second digit, and only 8 for the third digit. So again, you just need to multiply each of these numbers to arrive at the number of possible plate numbers without any repetitions. So moving on, the next counting technique, these are now called the permutations. And in permutations, what we want to count is the number of possible arrangements. In how many ways can you arrange a certain group of objects? So the simplest permutation or example is the arrangement of n distinct objects. And if there are no other restrictions, then the number of ways you can arrange n distinct objects is given by n factorial. By factorial, we just mean multiplying all the numbers from n and going down to 1. Okay, so for example, 5 factorial means multiplying the number 5 times 4 times 3 times 2 times 1. Okay. Similarly, if you have 6 factorial, then that is just 6 times 5 times 4 times 3 times 2 times 1. So in this example, how many ways can we arrange 10 people in a line? So you have 10 people, how many ways can you arrange them in one line? Since this is the arrangement of 10 people, then the answer is just 10 factorial or 3,628,800 ways. Okay. Note that you can think of this also as a problem using the fundamental principle of counting, where you have 10 blanks, and each of the blanks refers to a place in line. So how many people can you put on the first position in the line? You will have 10. Once you have placed the first person, then you will only have 9 possible people to choose for the second spot in the line. Once you have chosen the first 2 people, you will only have 8 people to choose from for the third spot in the line, and so on. So you will see that actually when you use the fundamental principle of counting, you will arrive at the same answer, which is the very definition of 10 factorial by multiplying from 10 all the way to 1. Note also that there is a way to calculate factorial using your calculators and using Microsoft Excel. So for your calculators, you just have to look for the n factorial or x factorial button. Okay. And for Microsoft Excel, the formula to use is equals fact and input the number that you want to compute a factorial for. So this is for Microsoft Excel. Okay, so moving on, we go to the next type of permutation. This time, we are going to arrange n distinct objects, but only take n r at a time. Okay, so to illustrate, in this example, the question is how many ways can you arrange 5 people in a line from a selection of 10 people? So you still have 10 people to choose from, but only 5 spots in line. Okay, so if you think about it in terms of the fundamental principle of counting, you will just have 5 spots in line. For the first spot, you have 10 people to choose from. For the second spot, you have 9 people to choose from. For the third spot, you have 8 people to choose from, and so on until 6. Right? And you multiply each of these, and this will be the answer. Now, this particular product, this is actually what we mean by the symbol NPR, right? Or N permutation R. And in this particular example, you have 10P5, which means you have 10 people to choose from, and you permute them. You permute 5 of them. Okay, so you have 10P5, and that is the same as 30,240 ways. Okay, so in Microsoft Excel, you can also compute this. You have a formula equals permute N and R. Okay, so for this particular example, all you have to do is to type permute 10, comma, 5, close parentheses, and that should give you the answer in Microsoft Excel. Similarly, if you have your calculators, all you have to do is to find the NPR button. So you start by inputting 10, and then find the NPR button, press that, and then followed by 5. So this is for calculators. Okay. So the next example for permutations, this time we are arranging n objects, but in a circle. So when we arrange n distinct objects in a circle, the number of ways you can arrange is given by n minus 1 factorial. Okay. So imagine that if you have a circle and you are going to arrange 5 objects, like in this example, we have a family of 5. So you will have 5 seats. And let's say you place father over here, mother over here, brother 1 over here, brother 2 over here, and sister. Okay. Let's say this is one possible permutation. Now, if you move each of these family members 1 seat to their left, okay, or clockwise, that is actually the same arrangement. Okay. So what we do instead is to count the number of possible ways to arrange them in a circle. You fix first one member and then count how many ways you can permute or arrange the other members, okay, or the other objects. So that's the reason why you have a minus 1. You fix one object. So as mentioned in this example, since we are arranging a family of 5, then the number of ways you can permute or arrange this family in a circular dining table is 5 minus 1 factorial or 4 factorial, which is 24. Lastly, the last type of permutation, this is the permutation where the n objects are not distinct. So as an example, how many possible arrangements are there of the letters in the word statistics? Notice, for example, that you have 3 S's in this word. So if you interchange the position of, let's say, the first S and the last S, then you're actually seeing the same word. So this is the problem now when your objects are not distinct. So now the formula is given by n factorial divided by n1 factorial, n2 factorial, up to nk factorial, where the denominator, we are just counting here the objects which are not distinct. Okay, so to illustrate for the word statistics, the number of ways we can permute this is as follows. So first note that we have 10 letters in the word statistics. So that will be for our numerator, you will have n factorial, 10 factorial. And then in the denominator, we're going to divide by the number of objects which are not distinct. So for example, you have 3 S's. So you're going to divide by 3 factorial. Okay. For the letter T, you also have 3 P's. So we again divide by 3 factorial. The letter A only appears once, so you just divide by 1 factorial. The letter I appears twice, so you divide by 2 factorial. And the letter C also appears once, so we divide by 1 factorial. Okay. So this, if you add the numbers, the numerical values in the factorials, you should have the same as the numerator, which is 10. Okay, so if you compute this using your calculators or Excel, then you will find the number of possible permutations for this one. And lastly, the last counting technique that we will discuss is combinations. So for combinations, our goal is to determine the number of ways we can select a group of objects. Okay? So we're not concerned with the arrangement of the objects. Our concern is just selecting. And the number of ways of selecting is given by NCR, or we say N combination R. So in this first example, how many ways can we select a delegation of 6 athletes from a training pool of 15? So using this notation NCR, okay, we see here that N is equal to 15 since there are 15 athletes to choose from. Combination R here in this example would be 6 since we want to select 6 athletes. So the number of ways we can select is 15 combination 6, or sometimes we say 15 taken 6. Notice also when we choose the 6 athletes, it doesn't matter in what order they are chosen. It's just we're counting how many groups of 6 athletes we can form. Okay, so now you can compute this number using your calculators. So for calculators, you will need to find the NCR button. So just type 15 followed by the NCR button and then followed by 6. If you want to use Microsoft Excel, then the Excel function is given by combin followed by N and R as the parameters. So in this example, you will have to type equals combin 15, comma 6 and close parentheses. That should give you the answer for the first example. For the second example, how many 5-card hands have exactly 2 kings and 3 aces? So we can think of this example or experiment in 2 operations. First, we select 2 kings, and then next we select 3 aces. So how many ways can we select 2 kings? There are 4 kings in the deck. Okay, from the 4 kings, we're going to choose 2. Okay, and for the second operation, we need 3 aces. So there are 4 aces in the deck. Out of the 4 aces, you're going to choose 3. And again, by the fundamental principle of counting, we're just going to multiply this. 4 choose 2 times 4 choose 3. And this should give you the answer to the second example. So this is it for the discussion on counting techniques. I will be posting some other examples for you to work on in our Canvas page. So thank you.